Hi, my name is John, and I am the author of the program that this video is about. I call it aMAZEing, spelled with the E, as you see, AMAZEING, because I like the word and it describes what you're about to see. This is a program that I wrote from scratch on my newest Texas Instrument graphing calculator, the TI-84 Plus CE Python edition. And just to explain the rest of the title screen, I'm including my Amazon address, mazes.com/Amazon, because I'm hoping that you'll use that address to start any of your Amazon shopping days, because then I'll make a small commission. I'm also giving you my paypal.me address as shown. So, and before I start the program, let me also explain one other thing. I will sometimes refer to pressing the run key above the trace button or something like that. Well, that's because this is what it normally looks like on the calculator, and you will see at some point it says run or edit or various other things. It tells you which one of the 5 function buttons to press. But I'm going to do the video with the screen over here because it's easier for you to read. So let's let this run in demo mode while I'm talking. That gives you something more interesting to watch. So 1, enter. This, as I said before, I wrote from scratch in Python, but I have written other versions of the Maze program in the past. And of course, I remember my overall logic. I probably wrote my first Maze program in about 1980 on the TRS-80 computer, and especially a few years later on my first IBM compatible computer, and eventually in QBASIC extended QBX 7, 7.1, and 7.2. That was one of my favorite languages many years ago, and I still have a clone of it from Q64.net that I sometimes go back to and use. The why did I get so into mazes? Well, I was born in 1951, and uh, in fact, in 15 days from now, I'll be 70 years old. Um, and what I found, I was fascinated and loved the mazes that were often printed on the backs of cereal boxes. And of course, I had to read every word on those boxes anyway. But one of my gripes with those puzzles was that they were always easy to solve, especially if you went backwards. Start at the end, go back to the beginning. And I surmised that the reason for this was that the person first created his answer and then he made his dead ends. So when I wrote my first program, I told it to create all the dead ends first and then, only then, make an answer. That first program in BASIC, I actually made it complicated enough that it made the dead ends both from the start and from the finish at the same time. And then it would make an answer by erasing one wall between those 2 sets of dead ends. This version that you're looking at here, though, I'm only making one set of dead ends at a time. And I'm not starting at any of the corners, but instead somewhere in the central area of the maze, anywhere from, I think, the second row to the second to last row second column to the second to last column. And that's only because if you run scale 37 mazes, it would be 4 rows tall. So I couldn't do 2. Okay, let's go on from there. So anyway, that's why I'm making dead ends first. Interesting, because I spent so much time writing new versions of maze programs. By 1987, I was writing a 2D maze program that I could put people's names in. And I remember one of the first people I made a maze for was the Methodist preacher's daughter in Collinsville, Illinois. So she and her mother came over to where my computer was above the computer store around the corner from their church. And I made um, Michelle is an Amazing Christian as a maze for her. The So then I would make mazes other places for people too. That was always fun. But anyway, one night, I think it was 1987, I had a dream. And in that dream, I was actually writing a computer program on my dream computer, whatever it was, and it was a 4-dimensional maze program. And I woke up and remembered enough from that dream that I was able to get up, turn on my computer, and start rewriting a new copy of my old 2D program to first make a 3D maze, in other words, like a building with stairways or elevators that would go from one floor to the next. And then after I got that one working, a few days later, I did the 4D version, which I thought of as time machines that would go from the building on Monday to the building on Tuesday, and then you'd go move around there a bit, and then maybe you'd go another time machine back to Monday, then time machine somewhere else to Tuesday, then you move around time machine to Wednesday, etc. And that logic was based on a dream, and I still remember the general logic from that dream. And I used the 4D logic from that dream when I created this 2D maze. Hint, part of it used the binary system. The But I've been writing computer programs for a long time. In 1978, actually late 1977, I started writing a 16K Level 1, Model 1 Radio Shack TRS-80 game to play Star Trek. Maybe your parents or your grandparents got a free copy of that from a Radio Shack salesman or something. That game floated from coast to coast. And I know, hearing from people who got the game for free, that there were Radio Shack salesmen in various stores, especially the computer centers, who would say, hey, buy our 16K computer and we'll throw in this game for free. Well, I didn't get anything from those free games that they got, that they gave away. They didn't give me a commission or anything. And in fact, they weren't honest enough to tell me they were doing it. I had to hear about it from customers. So if you did get that game for free, I would sure appreciate your making a gift to me as thanks now. I also had given a copy to some users group presidents, and one president, he was the president of the St. Louis Users Group, so I'll call him a slug for short, St. Louis Users Group. That slug told me one day, proudly told me, hey, I took your name out of the program listing, so now it's no longer copyrighted, so I can give it away to all my friends. Well, he went on to tell me, he said the reason he was doing that was he didn't think the game was worth $15, so he wasn't going to pay me for it, and he wasn't going to let his friends pay for it. Well, that wasn't very nice of him either. So I stopped going to his users group meetings. His loss. By then I had my store, so people were coming. I had a store called the Software Center, at one point called CompuTRS in Florissant, Missouri. So some people caught up with me there. One of the things you'll notice on these mazes as they draw is there are some mildly annoying holes in some of the horizontal lines. Well, that's because of the logic that erases walls to make the dead ends. I experimented to try to get rid of them. I couldn't get rid of them totally. I did at one point have a redraw utility in the program, but I removed it because for the harder mazes, it actually took too long to get rid of all those dents. So I left it in, but I don't think they're that much of a problem. But if you want me to put that back in, leave your comments at paypal.me/JohnnyBill, because comments with the donations will get paid attention to. Um, you'll notice once in a while there's a download URL on the screen. Once I get this program done in the next few days, I will post a full copy of this program there. And before I start getting into other things, let me also mention that if any of your parents were teenagers or kids in the late 1990s and went to AOKLYO Labor Day weekend events in Siloam Springs, they might remember meeting me because I did take my IBM compatible computer there and made laser printed mazes for everyone that wanted them. In fact, one Bella Vista pastor's grandson learned how to run the program and looked forward every year to making the mazes for me. He'd rather do that than go to some of the other activities. I'm sorry, I don't remember his name. Okay, um, let's look at the program itself. Oh, before I do that, let's look at it in manual mode. So you've seen it in a demo mode all this time. So I click the on button that gives us a keyboard interrupt. I click the trace button, which is under the word editor on my screen. So there's the program listing. Now the trace button is under the word run. Excuse me. And now manual mode is option 0. Now it asks for maze scale from 11 to 25, but 10 will work and 37 will work. 37 is too easy. You won't see many people wanting to do that other than the very youngest kids that you might show it to. Oh, see, they're right there. But it stays on the screen until you press enter, unlike demo mode that only leaves it on the screen for 5 seconds. Okay, press enter. Maze scale 10 is the hardest maze that it's possible to do with this program. And the scale number represents the distance from the middle of one line to the middle of the next line. So now you know the definition of scale. Basically 10 pixels from center to center. If we try to do scale 9, press enter, scale 9, you get a memory allocation error because there's not enough RAM to hold everything in memory. Perhaps at a later date, Texas Instruments will allow more RAM to be used. So I've allowed the program to let you put in scales down to 3 or 4, though you'd have to also change them to thin line mazes if you did that. And that would be a pain in the neck. So anyway, definitely works from 10 to 37. So now let's click editor and So I click trace, and there it is. And I'm going to have to take just a couple of seconds to disappear while you look at that first screen, and I'll be right back. And what I'll do is show you the program and tell you what some parts of the program do, because that might make it easier for you to understand the entire program and perhaps even use that to do other things. So I apologize for having to disappear. You can guess what room I went into. Information you did not need to know, correct? Okay, here you'll see I created an array called message, MSG, and it contains 7 different one-line messages from message 0 up to message 6. And creatively, I managed to figure out that I could intersperse remarks inside the message array declaration. So here we are, the title of the program, my copyright notice, of course, and a statement: if you enjoy my program or if you learned from its code, please send gifts. And there's my PayPal address, uh, paypal.me/JohnnyBill. Oh, that colon should be a period in www dot. Of course, you could just type paypal.me and it would get there. And there's my email address that will also accept PayPal donations. There's the URL for future program updates. I do have several pages on Quora.com where you can ask questions. It's the Calculator Python group, Calculator Programming group, and I do have a few other groups, but those were the 2 I thought I'd list here. And there's the reminder: when you do shop at Amazon, if you start at this mazes.com/Amazon address, I'll make a commission. And you don't pay 1 penny more. And there's my statement of please respect all of the time. And I talked about many, many days that went into this Python program, but it's been many, many months and years that went into all the maze programs that evolved into what you're studying today. There's a summary of what I've already told you about, starting with the 2D program and dreaming the 4D program, etc. Okay, here's where the program starts. Other than the message array above it, we have to use information from 6 different include files. So there's the import statements that take care of that for us. I turn off the axes because I don't want the X and Y axis on the bottom and the left side of the screen. I like it a nice clean screen. And as you may know, the TI 84 plus CE screen is 320 pixels wide by 240 pixels tall. So there's my plot window. The dir statement you see where I'm moving the cursor around is the directions array. Direction 0, first set of 4 numbers, has x 0 but y plus 1. In other words, it's going to go plus 1 up, and it's going to erase wall 1 going up, which is the equivalent of erasing wall 4 in the bottom direction from the new location. And that was direction 0. Direction 1 is x equal plus 1, y equals 0. That moves to the right, and its corresponding values of 2 and 8. And the same thing for direction 2 and direction 3. I won't bother to explain them. I don't remember if I use M for anything. I might be able to delete it and still have the program run, but I never tried that. Okay, here we clear the screen. And here I print 11 blank lines. That's so that my title screen will correctly display the last item where I want it to. The C equals center just allows me to use the letter C to center the text in the next few lines. So here it prints the title screen, line 2, line 3, line 5, line 6, and line 9. And of course, line 10 just plots the cursor where I want it to be. Then I do the ask the question, do you want demo mode or manual mode? So there's where it takes the input, do the integer of it, do the absolute value of it, and store that in demo. So if you type a decimal number, the decimal gets ignored. If you type a negative sign, the sign gets ignored. I tried to error trap that statement. If you type in a word, though, you might get an error message. While one, that just means while forever. And there's the if demo. If it's in demo mode, scale will be a random integer between 11 and 25. I mentioned that earlier. And it prints the scale, but so briefly you won't even see it most of the time. But if an error message happened, it would be on the might be on the screen along with the error message, maybe, maybe not. Okay, if it's not demo mode, then it sets scale to 0 and then does that while statement until you type a valid number. And again, I use the absolute value of input of integer of input of the input number. And though I ask for 11 to 25, it will accept between 3 and 37, but it will error message on 9 or less. And there's the reminder about 10 and 3 through 9. Okay, here, wide and high, that's just deciding how um, what the dimensions of the maze will be going along. So how many cells wide the maze is, how many cells tall the maze is, and then we calculate RR and CC to get the amount of space that will display above and below the maze and to the left and the right, so it doesn't go all the way to the edge. I think it looks better. And the lambda function is just something that will be used throughout the program to plot the lines where we want them to go. It's like an array or like a function, but you'll see us use it down below. I'm not going to explain lambda, but look it up in your Python documentation. But as you can see, if I were to represent row bracket 7 close bracket, it would use the 7 and go from there. I'm going to I'm going to ignore that phone call. Alexa, stop. Alexa, press 2. Sorry, I don't know that. Okay. How do I hang up, you idiot? It's someone in another area code, so I don't know who it was. So anyway, that's the lambda function, and my apologies for the phone interrupting this call. I did not want to answer during this recording. Okay, now here's a real fancy statement. Grid equal, and then this long statement. What this does is sets up an array that is wide plus 2 wide. In other words, if it's a 10 by 8 maze, it's going to make a 12 by 10 grid because I want a row 0 and a row high plus 1. and I want a column 0 and a column wide plus 1 that is outside the maze. And then what this statement does, it makes row 1 will have values equal to 11. Row high plus 1 will have values of 14. Column 0 will have values of 13. And column wide plus 1 will have values of 7. Well, if you'll remember, when we looked at the directions table, I talked about what each direction wall was equal to. Well, that means if I did put the redraw statement, the redraw function back in the program, those numbers would cause edges to show out for the outside of the maze. So anyway, I'll let you study that at your own later, but basically it's two nested for loops with the grid value equal to those statements being manipulated by that long statement. Okay, there's clear screen again. This color 000 is black. Here I make it, the pen, the lines will be drawn medium and solid. And here's my statement that puts the text in row 12, which is the bottommost row on the screen, a random message between 0 and 6. Len of message tells the calculator that there are 7 messages, but they are numbered from 0 to 6. And they are stored in the center. I don't use C for center here because it's only one time usage, because I went on to redefine C to be column. Okay, now for R in range 1 to high plus 2, plot the lines. So there's all the horizontal lines. And for C in range 1 to Y plus 2, there's all the vertical lines. That's what those two sets of statements do. And then pick a random row and a random column to start the maze. Earlier I said I thought it was row or column 2 to the next to the last row or column. That's what those two statements did. And I store 16 into that location because a non-zero location means the calculator knows that it's part of the maze. And 16, you might realize, stands for all walls, just like 0 does. Just think about and or mathematically instead of logically. Okay, and the count is 1. That's the number of cells that are currently in the maze. Now we change the color to white. An RGB technology or RGB nomenclature, 255, 255, 255 is white. When I was debugging the program, I used red so I could see it. And it plots a line to erase. Oh, that plots the line for the entrance and for the exit. That was these 2 lines. And now we're ready to start making dead ends. So while the count is less than the area, in other words, high times wide, and then it checks another while loop while the grid is equal to 0, where it is, which of course would be an invalid place because the maze has not been there yet, or if the position to the left, the position to the right, the position below, and the position above are all occupied, then it's going to generate another random y and another random x until that entire while statement up here is satisfied and is true, in which case it will be in a cell that is already part of the maze and has at least one neighboring position it can move into. In which case it sets f equal to 1. We're going to use f to keep track of when it's done. So while f is true, or while f is equal to 1, it's going to pick a random direction between 0 and 3, and it's going to set xx equal to the direction that x moves, yy equal to the direction that yy moves. O1 and O2 are the values that would go into the array for those movements. And it checks the value of f of the new position, y plus yy, x plus xx. And if it is equal to 0, it's going to cause the while loop up here to repeat. But if it is but if it's equal to 0, then that means it is a valid place to go, and it's going to drop through to here, where it will set that new, well, first it's going to set the old grid position equal to the old grid value or the value O1 plus 16. O1 being what direction wall gets erased, plus 16 identifying that it's part of the maze. And I won't tell you now what 16 means, but it has something to do with when I do rewrite this program to work from two ends at once. Then define the new y. Oh, RS, RP. Okay, yeah. RS and RP are the pixel positions for row Y, top and bottom. CS and CP are the wall positions for the left and right of the current cell. And if O1 is 1, in other words, if it's going to go up, we're going to plot a white line from CS plus 2RP to CP minus 2RP. In other words, the line above. If O is equal to 2, there's the command to erase to the right. If O1 is equal to 4, there's the command to erase going down. If O1 equal to 8, there's the command to erase and make white the wall to the left. Then increment x as needed, increment y as needed. It's either going to be plus or minus 1 for one of them, and the other one will stay the same value. Then change the new location's value, old value, which was 0. I could have done without the OR statement, and ORing it with the O2, the new direction value, plus 16. Take my word for it, it works. Then we do count plus 1, we delete. Okay, and then that's the end of making that maze. When count finally reaches area, the program drops through, the maze is complete, it deletes the grid from memory. That's an attempt to forestall a memory error later. And if it's in demo mode, sleep for 5 seconds and then continue. But if it's in manual mode, the wait key causes the calculator to wait until you press enter before asking you what you want to do next. And that's the end of the program. Boy, this has been 34 minutes so far. Hopefully, YouTube will allow this one to be posted. They would not post the earlier version of the program. If you have any questions at all about how this program works, feel free to ask your question on Quora. I will post a copy of this program to Quora and be happy to answer any questions any of you might have. You also have my email address. I only check it once or twice a day, so I play games the rest of the time. So, you know me by my work, and I don't remember if I mentioned AOKLYO, but if you had parents who were in the Arkansas, Oklahoma Lutheran Youth Organization, ask them if they remember me from Siloam Springs. So That's the end of this video. I hope you enjoy the program. I hope you decide to download it. And if you do buy this calculator from Amazon, please use my link. Though right now, as of today, Amazon isn't selling the calculator yet. I bought mine off of eBay. Okay, talk to you another time. Bye.